Hello and welcome to the course Climate Hazards and Disaster Mitigation. Today we are going to present a summary of drought estimation and assessment. So what have we learned so far? We understood the types of droughts, their drivers and causes. We discussed various drought indices, their usefulness, data requirements and limitations. We also evaluated drought characteristics like initiation, termination, duration, intensity and severity. So the learning objectives for today, that we are discussing the types of drought, their causes, drivers and impacts. Then we'll summarize the drought indices to characterize various drought types and present various approaches to estimate droughts and define drought characteristics. So to begin with, the very preliminary category of drought is meteorological drought, which arises due to deficiency in precipitation, and also it is sometimes combined with increased potential evapotranspiration over a large area, and that is causing meteorological impacts. Next is agriculture drought, which is characterized by reduced soil moisture, which could be due to below average precipitation, or it can be due to over extraction of groundwater or a higher amount of losses. Hydrological drought is usually associated with lack of water in a hydrological system, with abnormally low stream flow in rivers or lower water levels in lake, reservoirs or even groundwater. Then next is socio-economic drought. So when the human activities are affected by reduced precipitation and related water availability. So when your supply is less and the demand is more, then the socio-economic drought creeps in. And last is the ecological drought, where your drought starts to affect the ecosystem by degrading it. There is large amount of animal and plant mortality due to increased temperature and reduced water availability. That time your ecological drought sets in. So drought has multifaceted impacts on economy, social and the environmental sectors. So in India, IMD, that is the India Meteorological Department, is the authority which defines that the drought in any area, when the rainfall deficiency is greater than 26% is of its long-term normal, then officially the drought has set in that particular area. For entire India, they use the area weighted rainfall, which is also called the Indian summer monsoon rainfall, that is ISMR, to characterize all India rainfall anomaly. When the rainfall deficiency exceeds 10% and when the area under drought exceeds 20% of the total area, the situation marks that the entire country is under the drought effect. Now, even though India receives annually close to 120 centimeter of rainfall, the spatial and temporal variations is quite large. If you see on the Western Ghats region and on the far east, the rainfall is very high, but if you go to some parts of Rajasthan and Gujarat, the rainfall is very low. Consequently, droughts have been an ever-present feature at some or other part of the country. While the rainfall variability is one of the reasons, there are additional factors like excessive water withdrawals, unsustainable use of water, and not preserving our water resources that add to the drought severity. Understanding the cycle of drought, that what are the drivers. So to begin with, there is increased temperature, so that will cause more water more evaporation from the water bodies as well as the soil moisture. More severe and frequent droughts are being associated when there is higher temperatures being observed, because your crop and soil experiences large amount of stresses, because primarily your rainfall is less and the temperatures have escalated. So there is cracking in the soil and there is higher exposure of soil carbon to oxidation, that also increases the carbon emission to the atmosphere, and this cycle intensifies. So it is kind of it amplifies the loop. So we have to mitigate these conditions by enforcing proper measures, so that if at all the impact of drought is there, it is not felt that severely. So these are some few impacts. If the impacts on agriculture are very well known, that the farm productivity will fall down. Also it can cause outbreak of insects or increase wildfires, and alter the carbon and other nutrient rates. Transportation, if you are primarily talking about your inland waterways, then your river navigability is very severely constrained due to drought. Wildfires, drought is a bigger contributing factor to wildfires. If there are dry conditions, then hot and windy weather would be a fuel to the wildfire, and it could create large scale wildfires. Public health, because of drought the water levels are very shallow, so that the water quality is compromised, and it can result in increase in the illness and other diseases. Also drought can alter or degrade critical functions of healthy ecosystems, which can reduce plant growth or extinct some species, or landscape alterations can also be noted. And lastly, again, human as well as aquatic life are under a lot of stress when there are drought like conditions. So drought scenario in India, so this is the climate classification map from India. So you can see that these are the arid regions, these are the semi-arid regions. So they are characterized by large amount of water deficits. So if we talk about a large proportion of the droughts are in the semi-arid regions, where water constraint is much felt and there are a lot of losses, followed by the dry subhumid region where the droughts are second largest. Historically, we see that there have been a lot of recurrent droughts, with some years being surpassing the normal levels very alarmingly. So these are the states which indicate the frequency of drought is much higher. So you can see that from this study we have taken the drought atlas of India, where at state, district and taluka level the information is given that how many droughts have occurred, which was the most severe drought, and so on. Now, why does drought recur in India? Because the rainfall distribution around in the country is highly uneven. There are some regions experiencing extremely high rainfall and some regions very scanty rainfall. Also, there are regional disparities. Sometimes the northern part of the India receives very less rainfall in a particular year, and the other part receives very high rainfall, so that also adds up to it. If there is insufficient rainfall, that combines with unfavorable land-man ratio, which compels farmers in large part of the country to under distress, which are preliminary dependent upon the rain-fed agriculture. The reliance on groundwater and for irrigation aggravates these issues, particularly in the regions and the northern belt like Punjab, Haryana, where the groundwater levels are alarmingly low. There they do not have alternate sources for irrigation. The per capita water availability in the country is steadily declining because the water resources are limited, rather they are shrinking because of pollutants and other effects, and the demand is increasing day by day. So if we are not harvesting our water, then that could be a bigger problem in future. Coming to the drought indices, the very basic index, that is standardized precipitation index, it measures the precipitation anomalies at a given location, that how water is how the rainfall is deviating from its long term average. It can be calculated over different accumulation period like 1, 3, 12, 48 months depending upon the period of interest. What is the significance when you calculate SPI at a shorter time scale like 1 to 3? It can be used to gauge the immediate impacts of the drought, like reduced soil moisture, or there is a melting of snowpack or flow in smaller creeks. When you go for moderate durations, then it can be used to determine whether the reservoir storage is or stream flow is affected or not, and for very large duration, then it could imply reduced groundwater or reservoir recharge. There are other indices as well similar to SPI, SPEI, that is standardized precipitation evapotranspiration index. So your SPEI, that is P minus PET, so you can derive the SPEI, and based on that you can calculate the meteorological drought. SRI, that is standardized runoff index, and standardized base flow index are used for hydrological drought assessment. Similarly, standardized soil moisture index and standardized vapor pressure deficit index can be used for agriculture drought assessment. Apart from that, there are different indices like Parmel drought severity index, surface water supply index, agriculture reference index for drought. So there are so many indices which are there. Now there are some indices which can be also estimated using the satellite data. So this satellite data also provides valuable information. So this satellite data can be used, for example, NDVI, that is used for agriculture drought monitoring, normalized difference vegetation index, enhanced vegetation index, EVI, vegetation condition index, VCI. So there are so many satellite based data which can be used to harness this information. For hydrological drought, they can use NDWI, that is normalized difference water index, and so on. Here is a summary of the other drought indices. So this gives you a very fair amount of idea that which indice and what are the input parameters. For example, if you consider the aridity anomaly index, you should have P, that is precipitation, T, that is temperature, PET, that is potential evapotranspiration, ET is the actual evapotranspiration. So you can see that those indices which are data minimalistic, that is deciles, percentage of normal precipitation, SPI, so these are like data minimalistic, they require only one amount of data, that is precipitation. Then some indices require two data essentially, that is like aridity index, so they require P and T. Then again drought reconnaissance index, it requires again P and T, and so on. Now there are some constraints, like for this index you require monthly temperature values. For this particular index, which is crop moisture index, you require weekly values. Then there are some indices which require which can be used in a particular climate type. For example, here it is more used in Australian climate, and so on. So this is a compilation of all global indices. Then there is a Palmer drought severity index, which is very well known and used extensively in the United States. Then you have a crop specific drought index. So you can see that these indicated as red, that means they are too much data extensive. So that is how they have categorized these indices. Now let us understand how would we proceed. So if you have monthly total precipitation data, you can accumulate it using over different time periods like 1, 3, 6, 9, 12, etc. So that you get for the intended duration, you can derive the SPI series. So the process is same. If you, instead of SPI, you take any other variable like SPEI, then SRI, then SSMI. So you have to derive that respective time series, and then you have to fit here. So the parametric approach involves fitting gamma distribution. Usually it is a 2-parameter gamma distribution. So this is the equation for the gamma distribution. Now we have to estimate the parameters, where alpha is the shape factor, beta is the scale factor, and A is the constant which will be estimating in this particular equation, where N is the number of precipitation observations and X bar is the mean precipitation. Once you have that, you calculate this value using gamma distribution, and then you transform it to a normal distribution to get the SPI value. That will be your SPI at a given time scale. There is a non-parametric approach as well, where the marginal probability of precipitation is computed using the Gringotten plotting position. So in the floods, we have already seen what is Gringotten plotting position. So using this plotting position, you can get the probability, where I is your rank, N is the number of observation. So whatever empirical probabilities you get, they are transformed to a standard normal distribution, and you get the SPI. So if you want a short term analysis, you can have SPI 1, 3, for moderate term like 6 and 9, and for long term 12 and 24. So that scale you can select. Coming to the drought characteristics, so Yevgevich proposed the theory of runs, where he defined that any value of a parameter which is above that truncation level is called a positive run, and if it is below the truncation level, it is called a negative run. So this part is the positive run, and this part is the negative run. So if you have the SPI values, so as I said, let us say here in this, you can see the truncation level they have considered is plus or minus 0.99, so that is near normal condition. So the values fall below that, then they are drought, and values above that, they are called wet. Now these are associated with the probabilities because they follow a standard normal distribution. So approximately 68% of the area is occupied between the limits minus 0.99 to plus 0.99. So by estimating the probability, let us say your point falls here, you can estimate what is the probability of that drought to occur in that particular region, and if the value is less than minus 0.2, then the probability is too low and the recurrence interval or the return period will be very high. So T will be very high in that particular case. So based on the SPI value, you can delineate whether it is a wet period or a dry period. So dry period where we are interested in is the drought. So this is the initial point, that is the initiation of drought, this is the termination of drought, and drought duration is Ti or Te minus Ti, that will be your drought duration. If you sum up all the values of SPI in the drought duration, that will give you severity, and your intensity is your severity divided by the duration. So this is a summary of all. We can calculate the number of drought events. So as I told, this threshold is subjective, different studies take different threshold. This is a drought severity and the drought intensity. Now coming to wet to dry transition. So first you define the transition states, whether it is a dry state or wet state depending upon the truncation level thresholds you consider. So if we are considering minus 0.8, then it is a dry state, and plus 0.8 it is a wet state. Now then you have to identify which is the first month, dry month followed by a wet month, and vice versa. So there can be 4 kinds of transition. There can be transition from dry to dry, dry to wet, wet to dry, and wet to wet. So 4 kinds of transitions are possible. You can count how many number of transition occurred. Here preliminary, if we are interested to wet to dry ratio, so we'll count how many dry to wet transitions happened and wet to dry transitions happened, and then the wet dry ratio can be computed as well. However, if you are going by this classification, let us say you have a matrix. So we denote it as wet, dry, wet and dry. So it is a 2 by 2 matrix. So let us say if there are total 40 number of events, out of that there are 15 dry to dry transitions, there are 5 dry to wet transitions, there are 10 wet to dry transitions and 10 wet to wet transitions. So you can easily compute the probability as wet to wet is 10 by 40, then dry to wet, so that is 5 by 40, then wet to dry, that is again 10 by 40, and dry to dry is 15 by 40. So this will give you the transition probability matrix. So these transition probabilities would give an idea that how a state transits and which is the more predominant transition state. Next is we can also visualize all these things in the India Drought Monitor. So this India Drought Monitor is developed by IIT Gandhinagar. So in this they have classified, so here the threshold they have taken is minus 0.49. So based on that they have classified ranging from abnormally dry to moderate drought to severe drought to extreme drought and to the exceptional drought. So the drought early warning system is provided. You can get the time series of droughts, you can get even the forecast for droughts, you can monitor stream flow, which drought types are there, you can see. So for example, from this image you can clearly see that these regions are facing exceptional droughts because your if the value SPI is considered, so that SPI value is very low. So a glimpse before the hands-on session. So in this hands-on session we will derive the standardized series of a given drought index. We'll compute drought indices using the Green-Gorton plotting position. We'll identify the drought events, we'll estimate the drought characteristics for all events, and then we'll do a temporal analysis of drought characteristics. So all these things will take a precipitation time series, we'll calculate that, and then we'll take, let us say we start with SPI as a indicator, then we will use this non-parametric plotting position, and then all the indices will all the characteristics will calculate. So this exercise will be purely in MATLAB. So thank you for your attention. In the next lecture we'll focus on the hands-on session on assessment of drought characteristics.